For what values of x do the following Maclaurin series converge? So the first one we have is f of x is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial minus x to the 6 over 6 factorial and so on. It so happens that this is the expansion for cos x. The general term here would be x to the 2n over 2n factorial. We can see these are all even numbers, and the factorial on the bottom is the same as the power on the top. So a ratio test would look at un plus 1 over un in modulus, because we're not worried about the sign of it. And that would be x to the 2 n plus 1 divided by 2n plus 2 factorial, and we're dividing by un, and in the usual way with fractions, keep, flip, change. So we're going to flip the second fraction, un, upside down. So we get that. And then we'll multiply instead of dividing. And if we simplify that, we'll get x squared over 2n plus 2, 2n plus 1. And if we look at the limit as n tends to infinity of x squared over 2n plus 2, 2n plus 1, then no matter what x is, that is going to tend to 0 for all real x. So therefore this one converges for all real values of x. If we look at this second one, we don't need to use a ratio test. In fact, it can be difficult to use a ratio test here. However, we can spot this as a geometric series with a equal to 1 and r equal to x. And we know that such a series will only converge if mod x is less than 1, or in other words, x is between -1 and 1.